Welcome to the Wingly Update, name to be decided. Forget everything you know about programming language for the cloud. Now, welcome your host, Eyal Keren.
Hi, how are you doing? And welcome to the Wingly Update, name to BD. I'm excited, not excited too. I'm just excited right now. I'm anxious and nervous. And I have Chris here, our man from Boston.
Hey everyone.
Chris is a developer at Monada, and he's an awesome guy and a great developer. And I'm getting to know him here because we just had an offsite in Israel. So we want to take this opportunity to have Chris today on our show. Thank you for coming.
Yeah, it's a pleasure to be here, Yal, and it's also just a pleasure to be visiting the offices, visiting Israel. Great, time away from the Boston cold that I'm used to.
Yeah, we had great weather. Yeah. Today on the show, we're gonna have. I'm gonna be kind of recapping what is Wing about, kind of going through the same stuff that we might have seen, but adding some new features. And then we're going to have Chris talking to us about, we're going to contribute some code, basically, right? We're going to add a feature to the SDK, and we're going to talk about this. And then we're going to have Shai, who will be joining us to go through the contributing guide, kind of a step-by-step walkthrough. Unfortunately, we don't have Revital, and we don't have Mark the DJ today. So we're thinking about them, and I'm sure they're watching. I'm sure they are the watchers.
We're looking for you in chat.
If we have less than two, okay, we have Hassan. Okay, great.
And Uri.
Oh, nice. Okay, great.
Awesome.
Great. So we're among friends.
That's good to hear. So what's been contributed to Wing lately?
Yeah, so I'm gonna show you. Basically, I'm gonna go through the entire process. And Wing is we kind of believe in short. We kind of believe that something was taken, something is lost from the developers. Basically, if you're writing an application, developing an application for the clouds, basically you don't have the flow. There's no option to go into the flow. You can't run your application locally. You can test it. I used to, when we talked about this, we used to write software, fast iteration, change things that we want, and we want to fix this thing. So if you can just present my screen, I'm on full screen. Basically what I'm going to do, I'm going to write a new Wing software. We have already seen it. It is another incarnation of the to-do app, but I'm going to go take a different path. So I had to install Winglang, and I did npm install on the Winglang library. And basically, I'm going to start a new just app.w, simple app.w. Let's get this here. Let's get this a little bit bigger. Oh.
So just a single command to install the entire tool chain, basically. Is that how it works?
Yes, yeah. Thank you for doing this, man. Exactly. This is exactly what you need to be doing. Yes. This is exactly what you need to be doing right now. So a single command to install the entire chain. Yeah. Okay. And I'm going to basically do Wing, and I'm going to use a new command. So the Wing test command, and I'm going to run Wing test on app.w. I'm just going to test probably the best code I've ever written. You can't see any bugs. There's no missing documentation. And
the best code is the least code. That's my attitude.
Yeah, there's no bugs here. I can tell you that. And I'm going to run it, and basically it says it passes. So it's not even that it's the best code. It's also kind of
the correct
code. But there's no in-flight test. So let me bring in-flight test to the application, to the way this Wing test command currently works. Just kind of hacky way, but very powerful. If you have a cloud function with the name test or test column, it will run them. So let's run our first test. Bring cloud. This is a little bigger. Let's get this a little bit lower. And do new cloud function in flight SDR.
So do we have a concept for this application right now, or?
Yeah, so I'll be creating the same to-do React application, but I want to do this TDD style.
Okay, so
we have a testing
test-driven development.
Yeah, we have testing framework.
I think
Why
some
not?
people know that.
Why not do this TDD style? Okay, let's do this like this. Now we're going to write the first, I hope, failing test that you ever seen on TV. The first wing test to fail on TV.
It better fail. Okay, thank God.
Yeah. Let's see why it fails. Let's see. Okay, it failed from the right reason, which is important. So this is the best. I mean, the first test fail. Do we want to run it that it works just to see that it also works? Why not? Okay. So and this is the first passing test. Okay. Great.
Very good.
So now let's create a to-do app. So let's do. We already seen this to-do app. So we're going to do let add. Sorry. Let's call let ID. So how are we going to do this?
Do we want to introduce a resource maybe?
I want to basically go. I want this test to be add a new task and get the task. That's what I want this test to do. So I will be probably doing add task dot invoke. So this is going to be a new resource. I'm going to invoke
the function.
Yeah, the cloud function. This is a task with this task, and this will return an ID, right?
An ID.
Yeah.
Some kind of string we can assume, but
yeah, basically it's a string. It's a good assumption. And now we're going to do assert, and this is a new task. I have to say that the setup is kind of leaning down. It's not nice. Equals get task dot invoke and that ID. So
gotta say this test is looking good, but I'm kind of missing that like JavaScript triple equals. I don't know about you, but
I agree.
You know.
I agree.
It's one of those like downsides of a new language, right?
Yeah. I mean, maybe we should add four equals. Just maybe something should be 4 equal. So we have cloud.function, this thing, and then it invokes the task and insert whether this is a task equal. I mean, we do have this nice waterfall of nodes. Yeah,
it's a work in progress.
So let's do wing test on unknown symbols, add task, get task.
Hey, compiler errors are good.
Yep. And now let's do let get task equal in-flight. Oh, sorry, cloud function, right? Cloud function in-flight str this, sorry, as we already talked about this. This is kind of annoying. Someone said in the previous episode that you have to kind of as get tasks, and so this is.
But this won't be a test, right? This is like actual.
Yeah, this is the code, the code on the test, right?
Yes.
Yeah. So why is it mad at me? Do you know?
Maybe.
We get some
Maybe you need something.
Okay.
The chat
Okay.
about the plant.
The plant. Okay. Wilson.
Yeah, Sabotai Lord is saying that the plants need some watering.
Oh, the plant needs some watering. Thank you, Sabotaro?
Sabotai Lord.
Sabotaro, okay.
Do you think it likes sparkling or maybe keep it to yourself for now.
Torture. Having someone needing water and then drinking in front of their face.
Nice. So let's add this thing and let's do the add task. This is a get task. Oh, add task. Let's do add task here.
Add task, perfect.
And let's call this add task as well. And let's do this thing. Let's go to get task for a second.
And so both of these, like cloud function, I mean, just to like get people up to speed here, you know, these are both what if I'm compiling to AWS, that's going to be like a Lambda function?
Yeah, so yeah, exactly. So the cloud function, we haven't created new. So a cloud function needs to be instantiated.
Exactly.
A new cloud function. Thank you, man, for.
Actually, I wouldn't have caught that, I think.
Yeah. So this is a weird a mistake. So a new cloud function basically will be provisioned as a Lambda function if you're not stating that something different. But you will be able to change it. Of course, it could be a different target, and it's going to be a Google Cloud function or an Azure function. But you can also kind of configure this to be a container. I mean, it's possible to configure this how it is deployed, to control how it is deployed.
Very nice.
So now we have this test that basically should fail, and it's failing because I didn't implement the function, as you can see. And now I'm going to cheat like you should be cheating, and I'm going to do return. This is a task, and I'm going to have.
So it's almost like we're kind of like stubbing out the behavior.
Yeah. So this is a classic TDD pattern. You just say, you know what, let's pass the test, and now let's remove all the duplication. It's kind of advanced. I don't like doing this, but but it's basically it's just a good place to say now we have an application. We have two cloud functions. Let's do wing it app.test, and we're gonna launch the.
Ooh, wow.
This is the Wing console. So the Wing console is basically a simulator. It's running the simulator. So we have an implementation of the entire SDK inside localhost, kind of running on your localhost.
And it also shows you all the resources that are inside. Okay.
Right. So when you're building when you build in the cloud, this is basically what you're building, right? Okay.
So you can kind of drill down into like what are the things it's creating?
Yeah,
okay.
Exactly. So we have the root device, and then we have three Lambda functions here, or basically cloud function here. And you can see how they invoke each other. You can see that the test invokes both get task and add task, and you can see this indication over here as well.
That's convenient.
Yeah, it's nice. It's very nice. Now I want to do let bucket equal new cloud bucket, and basically I want to implement some more code just to make sure that we're seeing this. If I add this and I go over here, back, I now can see the cloud bucket. So let's also take this full screen. I can see the cloud bucket here.
It has zero files in it.
Yeah, zero files in it, right. I can go back here, see there's zero file in it. I can invoke those functions. I can run this function, it's going to be invoked, it's going to run something. It doesn't do anything to the bucket, so we're not going to see it.
Yep.
But basically it ran the tests, okay? And the tests are passing, although the code is lying. And now we're going to just very easily going to implement this. We're going to do, so this is going to be the title, not just a string. Bucket dot put. I need a name for the file, so I'm just going to call it A. And I'm going to put the title. Great. And here, instead of doing this, I'm going to do return bucket get. What I'm going to get? I'm going to get A.
Get A,
Yeah. It should be ID, but I'm not using the ID. Let's run this. Let's run the wing test for a second. This passes, so this is working. There's still a bug in the system, but it's working. And then here we can see that we have all those interactions. And a shrewd person like yourself might see that there's more interaction.
Yeah, that doesn't seem right.
Yeah, so we're still seeing that the get task and the add task basically is calling all different functions, like all the API on the cloud bucket. This is because, why is it basically, do you know?
Well, I do know some of the reason. The SDK and compiler, they're kind of working in harmony to generate these cloud apps that you're compiling. And right now, we need to do some static analysis basically in the compiler to say, okay, these are the methods that are getting called, and then pass that information to our SDK, to those resources. And so we have part of that wiring done, but it's not finished quite yet.
So it's kind of very eager. It takes everything.
Yeah. So we're assuming the worst, but this means on AWS you're going to get all the permissions, but just for that bucket.
Yeah.
So it's not least permissions, but it's okay.
Yeah. Right. But we want to fix this.
Not okay.
Yeah. It's not really okay. We want to fix this before the beta because this is one of the things I mean, you're not allowed to open write permission. I mean, it doesn't make sense.
Yeah.
Right. So this is something we want to fix before we launch the beta.
And I think something even cooler will be like, if you're always putting objects in a certain prefix, like maybe we can just grant permissions to that prefix of the bucket.
Yeah.
So you can do things like that.
Makes sense. Okay, so the next thing for us on this, thank you for this. The next thing for us will be replacing the A. So right now we're using a single ID. I can add another test to break this, but it doesn't make sense. I mean, it doesn't
Yeah, you
make sense.
can quickly see how
Yeah,
it'll
yeah.
fall through.
So we're gonna be kind of naive about this and let counter equal 0, and we put the counter here, and the counter is an int, as you can see, and then do counter equal counter plus 1.
Does Wing just have like a single number type? Is it?
Yep.
Okay.
Just a single
so
number
very
type.
simple.
Yep. So what happened here? If you go up, I try to compile this, and basically cannot assign counter because it is a constant.
So in Wing, everything's immutable by default, right?
Right. So
And why do you want that? Why do you?
why do I want immutability?
Yeah.
Why do I want this? Do you know?
Well, I think. Actually, I don't know.
I mean, if you change, first of all, our runtime runs because we have inflight function. Inflight function runs in different contexts, in different runtime.
Yeah.
So it's not very true. If you want to change something, you want to know that you're changing it.
Yeah, you can quickly imagine some surprising behavior where after line 8, you change counter. What's the value of counter inside?
Yeah.
It's actually not really clear when you're reading it.
So are you sharing information or not?
Yeah. Then you suddenly refactor your code and the behavior change.
Yeah.
That's scary.
Yep. So this counter is immutable, and we can't assign it inside this lambda function. So basically, we're going to add new keyword that was just introduced to our language. Probably 4 days ago, 5 days ago.
4 or 5 days ago.
So the var. So basically, the var makes the let.
It can vary. It's a variable.
It's a variable. So we're not doing let versus var. We're doing let var counter. Now it means that the counter is reassignable. I wouldn't say immutable. So because the actual number is immutable, but the variable is reassignable.
Exactly.
Yeah. And now we're going to run this, but unfortunately, it doesn't work still. And the reason it doesn't work, because I haven't saved it, maybe. I mean, it's true. It's not supposed to work, but not for that reason. Okay.
Okay. Can't capture.
And now I can't capture a reassignable variable counter. So now, till now we were kind of fighting with the compiler. Now the compiler tells us, listen, this is not what
Here you tried adding the mutability and it still rejects you.
Yeah, exactly. This is what you want. This is not possible. That's basically what the compiler tells you. Oh, you want to do this? I mean, we're not capturing reassignable variables. We don't have the same runtime. And we have a solution for this. And I mean, it's not going to be
The thing
shocking.
is, this value, it's in a single place. Like,
Right.
how is that value getting shared
Right.
among these cloud functions?
Right. Exactly.
We need to think smarter. Like, we want something that works atomically. What if 2 different cloud functions are calling add task, right?
Right. So what would you do? I mean, you would probably go here. You're gonna go, okay, we can be non-reassignable, and say new cloud counter.
Right. So this is one of the newer resources we've added.
Right. So we're excited about this resource, I would say, right? I mean, it's
Definitely.
it's an exciting resource. And now I'm basically changing the code a little bit just to. I think that should work like this.
Yeah.
Okay. Nice.
Perfect.
So now we changed. We went through we had a counter and int. Well, let is constant. You need to make it reassignable. You want to make it reassignable. You had a var. So let var counter dot 0. And then the compiler told us you can't change this. If you want to change it, you need to be explicit. You need to change a resource, and you need basically a resource that is capable to work with concurrency. And now we have the cloud counter, and it should be still working, but it's not. Not sure why.
No such.
That's a weird. That's a surprise. What? Oh. I'm not sure. No. So some kind of problem. What are we missing? I think we should. I'm not that interested in figuring this out. Can you see the problem? Oh wait, this needs to return string. This is the problem.
That could be it, yeah.
Yeah, this needs to return counter in. No, I mean this is annoying. Okay.
Yeah, so you want to save that to a variable probably.
Yeah. So let counter equal, or ID, let ID equal this. And oh, now I see my problem. I had a bunch of bugs here. Okay.
Yeah.
And now here I need to put ID. Yeah. Okay. Sorry.
Yes, this makes more sense.
Yeah. Does it work? Okay, I need to return this ID. Sorry. Okay. So we need to work on those error messages. Basically, what did it panicked? Basically.
Yeah, I have a feeling that it must have panicked.
Yeah. Okay. And
so
if we go, yeah.
That's a GitHub bug report right there.
Exactly. Okay. And we go to the Wingit. Basically, we have the entire application with us. And we have the counter here, and we can run the tests. And we already seen this. I mean, I can go into counter, I can increment this, I can run this test here. Let me run it, and I will go back here.
And let's look inside the bucket and actually see if we can find that task. Right?
Yeah, we got the file here, basically,
Okay.
and we can download it. Exactly. So everything is working as expected.
The console is cleaner.
Yeah. It's a new feature that with the descriptions, with the display, and now it's much cleaner. Much cleaner. I really love it. Taking shape.
And what if you want to deploy this to AWS?
So we know this, we've seen this before. I basically can just go here and do wing compile dash target AWS TF or TF AWS? Is it AWS?
TF AWS.
Yep. Thanks, man. TF AWS and the app, and it will generate the kind of the Terraform stack with the CDK, and when we know we can deploy this, and we've seen this, and we're not going to do this again.
Very nice.
Yep. Great. So
that's wing test, basically.
That's basically wing testing. So actually, wing test, cloud, var, mute.
And what kind of things do you think we're going to be adding to wing test in the future?
So the nice thing about wing test, which is actually exciting, this is the test itself is written in cloud resources. So this can be, we're not doing this yet, but this will be able to be running on any designated cloud. Because eventually this is the entire code here is cloud code that uses cloud resources. So you can run tests simultaneously.
So maybe like when I'm deploying my app to CI, like at the beginning, after it deploys everything, it can just like run some sanity tests in the cloud.
Yep.
And like if something happens, then we roll back or we report an alarm, something like that. Okay.
Right, exactly.
That's very nice.
That would make sense. Yep.
Cool.
Thank you.
Thanks for sharing, Eyal.
Thank you. Now I'm going to do this. I'm going to connect myself, disconnect myself from this and move this to your side.
Okay, let's get this set up. Okay.
And thank you. So my part was much longer than I expected. I have to admit. I was thinking about 10 minutes. I don't know. Basically, the time was running. And I told you something about minutes before. So take your time. If it takes.
Sounds good. We'll see how far we get.
Yeah. So what are you going to show us?
So today we're going to try adding a new API to the bucket resource. So the resource we just saw.
Okay.
And the concept, so in the SDK, if we go to the Winglang website, we've actually written some docs sketching out what kinds of resources we want to include in the SDK. So on the right-hand side, you see bucket, queue, function. And we're kind of experimentally, making a roadmap of what APIs people want for like the most common 90% or 99% of use cases on the cloud.
Yeah.
And one of those for buckets, so we've shown how you can put objects in buckets, get objects, list all the objects. Some of these are already implemented. But another really common use case, as you can imagine, is like putting an object at deployment time.
Yeah.
Like what, you have a static website and you want to upload that file, even if it's updated each time you run a deployment.
Classic use case for that.
So our goal today, we'll see how far we get, is to add this add object method to the SDK.
So the SDK, what's the the boundaries of the SDK
So the simple mental model is that the SDK is just all the batteries included, resources, and some of the other APIs that come included in the Wing language. So for loops, not necessarily part of the SDK, but everything under that cloud namespace, that's probably under the SDK and so on. So the place we're going to start is in this cloud namespace folder. And this is kind of what defines the high-level abstract interface. So here's all the in-flight list of methods, which are currently modeled in TypeScript, basically using this interface. And then all the pre-flight operations that you can do on this resource, these are all part of the bucket, this base class.
Yeah.
So we're basically going to add a method named addObject, and I have Copilot for me, which is, it sometimes gets ahead of itself. But yeah, we want to add. If we look at this API, actually we have this idea that you want to put a lot of kinds of objects in a bucket, so maybe it'll be some blob type.
Okay.
But for today, just to simplify things, it's just going to be a string.
String, yeah. That's
this will simplify.
It's interesting that the first thing we're seeing is that there's a camel case in the documentation, but you're writing this in sorry.
So, yeah,
sorry, there's a snake case in the
there's snake case in Wing, but all the APIs in TypeScript, we're writing them in snake case. This is kind of like to play well with the rest of the construct ecosystem. So we're kind of building on the shoulders of giants there. And
this will be JSified.
Yeah, we're using this tool called JSII under the hood. And anyway, it will all get fixed.
Got it.
Or adjusted under the hood.
Got it.
So what are we doing here? Well, this is actually just an abstract method. So we're basically just going to say void abstract.
Okay.
Okay. Awesome. And then here, this is kind of just like a proxy, or like a stub instance that doesn't really need to do anything, but we just need to satisfy. It's kind of related to how, this cloud class gets, bucket class can get turned into a simulator bucket or an AWS bucket, but
we need to
I could talk about it for hours.
Yeah, we need to feed the static compiler for a second with something that it will never chew in when you actually compile, right?
Yeah.
Something.
Okay, so there's keen body. Let's keep going so we make good time.
Okay.
Okay, so let's actually start with the AWS implementation.
Awesome.
So really, we want to implement this for as many clouds as possible. And it can be different, obviously, because of the APIs. So let's see, public, blah, blah, blah. Okay, so what are we doing for addObject? Well, long and short, Terraform and AWS, they have an API for creating new bucket object, which we're actually already using somewhere else in the SDK. So I might actually copy some of the code.
You showed me this before. This is where we basically create the Lambda archive. I mean, it's we need to create that that Lambda file, that archive.zip file. Let's get uploaded to Lambda.
So we add this import.
Okay.
It's worth emphasizing the pre-flight. So.
It's a pre-flight function,
Yeah, so this is, pre-flight.
So Elad's mentioning that it's worth emphasizing that this entire kind of API is a pre-flight API because the addObject function will run during deployment, and that's part of pre-flight.
Exactly. So this doesn't actually get run in the cloud. It will be running on your machine when you're running Terraform, or maybe on AWS's machine in the future if you have CloudFormation, but that's kind of a detail. So we've got this S3 object, and let's actually test it. So in the SDK, we've got this kind of little sandbox thing that's just helpful for testing things without needing the whole Wing compiler and language. So
Yeah.
this looks a little bit like Wing in the sense that there's a queue or something here, but
Yeah.
there's also a lot more because the compiler abstracts so much stuff. So
Yeah, and we're saying you need to provide the scope and the name, right? I mean, because
Yeah.
this is not Wing. Yeah.
yeah, in Wing, some of this comes automatically.
Yeah.
So okay, so Copilot's helping me already, and this is what the API looks like, right? Add object.
Yep.
That looks legit, right?
Yep.
So let's try synthesizing that. Okay, that worked. Let's take a look at what it generated. So in here, if we dig into the directory, yeah, we get this huge Terraform file
Yep.
in JSON. And so yeah, we see a bucket, policy for it, some encryption for it. So that's just standard. And the new thing that we got is
Yep.
this S3 object. Okay. And we could try deploying this if we really are curious. Let's keep going on.
Yeah, I believe you.
Okay. I appreciate your trust, y'all.
Yeah, I
It's-
mean, I think if it's not going to work, we can fix this. But I think I'm more keen to kind of understand this entire kind of from an end-to-end
Exactly.
perspective. And then figure it out.
So the other half is we want to implement this feature for the simulator,
Okay.
right? And so you can see, yeah, we're already getting this compiler error because it's not implementing the add object.
Yeah, so I want to take us back a second. So I'm kind
Yep.
of because I need to kind of build something and I need to understand something. So we added the add object API to the bucket. It's a pre-flight API. It gets a path and right now a string. It will upload this on deployment.
Yes.
You've implemented this through the CDK for Terraform, basically. You've created the class.
For AWS.
Yes, exactly. Now, simulator, I mean, the use case in my mind was a static website. I mean, that's what you can imagine. In the simulator, when you do the same, what's going to be, how will the end result look like? I mean, what's the...
Well, the end result will look like a bucket that's really modeled in memory or like on your disk on the computer. So this is something that's like very easy to like unit test because you don't actually have to make any network calls anywhere.
Yeah. So yeah, I could basically go to the, I mean, if the simulator implements it, I still can go to that website that is hosted in my simulator and see that how this file being served to me.
Exactly, yeah.
Okay.
I don't know if we have like the files serving like,
Yeah,
I don't know if it sets up,
yeah.
but we will see like in the simulator.
That the bucket, that the file exists there. Yeah.
Exactly.
Okay.
Okay, so now we want to implement this method. So let's make it public just to be explicit.
Yeah.
And add object. So really, we kind of need to. There's not much work that happens pre-flight in the simulator because all we're doing is actually we're generating this simulator file. It's like .wsim.
Okay.
And that's the thing that really gets run and that does the simulating.
Okay.
So here we just want to basically we have to synthesize this schema, signaling like how to simulate this resource. Whether it should be in a function
Public or not
resource, we
public,
might include the code.
Yeah.
But here we're probably just going to add a field that says like, okay, there's something missing already. But we want to say like the initial objects in the bucket, uploaded to the bucket. So whenever we simulate a bucket, it will start with these. Yeah. And it's the same as like deploying. That's basically the behavior we'd be getting on AWS. Okay, so and we're saying this is like a map from strings to strings.
Makes sense.
Okay, and so then we just fill it in. So yeah, based on this, we need to somehow track the objects whenever they're added. Yep. So let's just make something private. That looks good. Perfect. That was easy.
Yep.
Okay. Well, we're not done though, right?
Yeah. So basically, we just created this private data, basically kind of private record from string to string. That's it. We just pass that along. Okay.
Yeah.
I'm good.
So we've kind of implemented like the pre-flight side of this coin that is the
Right.
resource. Then there's the in-flight side.
Right. Because the add object is kind of weird. I mean, there's a pre-flight, although it's a pre-flight thing, something needs to upload this when it goes.
Maybe even helps to like emphasize, that like if we do bring cloud, in some new Wing file, right? Like, if you do a new cloud
bucket.
function,
Okay.
say we have a bucket
Yeah.
in new cloud function, I'm just going to do some pseudocode here, but like here we couldn't do bucket.add object because it's actually a pre-flight method, and you'll end up getting a compile
Yeah,
error.
I can do bucket.put here if I want to do
Yeah, here you'd have to do bucket.put.
Yeah.
But if you move it outside, then it will be fine.
Yeah.
Obviously, my VS Code extension is with the old version of Wing, so we don't have it.
Of
It
course.
gives an error, but that's the concept.
Yeah.
Let me delete that. Okay, so in flight, we basically have this class for each resource that says how to simulate it. And what is a simulation? Well, it initializes the resource, a cloud engine. Cloud providers already do this. They spin up resources when you ask them to create an S3 bucket, for example. In this case, we actually kind of do some stuff in the constructor as well.
Okay.
This is just like if you need to do something asynchronously, you also have that option. There's a way to clean up things when you're done with the resource. When you're deleting an S3 bucket, AWS does something.
Okay.
So does the simulator.
Makes sense.
And there's also a method for every single in-flight method.
Yeah, of course. Okay.
So we're not going to be touching those, but we're just going to be...
We're probably going to touch the init, right? I mean,
init,
when we're starting, I mean, we need to basically upload the file.
Yeah.
Yeah.
And so we actually have these props already. That's basically the information that we passed from this JSON object. So we're going to say, let's actually save these initial objects. And then say, okay. So that's already kind of completing stuff for me. Very nice.
Very nice.
This is just how development works today. It's awesome.
Wow, it's crazy.
Okay, finally, we're going to say, what are we going to do? Well, for each initial object, we actually need to create it, put it in this file directory.
Yeah.
Because we're basically being very silly and sneaky in saying, we'll simulate S3 with an actual file system.
Okay.
Yeah. It's a folder in your system.
We can call put probably. We can call put as well.
We could do that. Well, let's try it.
Yeah.
Okay, so.
And I think it's interesting because the pre-flight and in-flight in the simulator are
there's
the same time.
Yeah. You can,
deployment time and runtime.
You can only rely on this specific resource to be alive at this phase, right? I mean, because it's not really after deploy.
Dependencies.
Yeah, and all the dependencies. Although, and all the dependencies.
Yeah, you can also rely on dependencies.
Yeah. Okay.
So we could talk about more, but we want to say this dot put key value, and that seems pretty straightforward. I mean, now is this working? Well, there's two things we can do. The first that's really important is actually to write unit tests.
Okay.
We can try sketching out just one maybe for this for now.
Okay.
Can you run one in Wing?
Can also try it in Wing, although we need to like build the.
Build the SDK and your CLI should work.
So let's just try compiling here. Ooh, okay. It is complaining.
You have a bucket.
So it's complaining that
Azure bucket,
we added. It's for sim and. We implemented this new method for the simulator in the AWS, but not for Azure. Solution there is really just to say, okay, this is not really supported yet today. More work is needed. So.
But we need it's something we'll be coming across a lot in the beginning. So we need We need to understand how we don't
on
this.
Azure yet.
Yeah.
Link to a.
And then we want to link to an issue,
Yeah.
yeah.
Yeah, but okay.
So that I will do that as a to-do.
Yeah.
Now, okay. And of course, this needs to have the right arguments, or else it's probably going to whine. Body string. Key body. Okay. Let's see if we got some juice here.
Yep.
Okay. And now, I think we just run what? NX run wing. I think it's like wing build. That's not it. We're constantly like working on this iteration cycle, but okay. So we've got that building, but just to sketch out like how these. Oh, it's
this
actually
was
kind of
fast.
fast.
Oh my God.
Okay. Well, let's see if we can get that working. Okay, so let me open my like little wing testing space.
Okay.
And okay, so I was already trying this out a little bit earlier today. So this should work in our ideal world. I'll kind of like delete all the other stuff. So we want to. For now, I'm just gonna kind of directly find the path of the new CLI binary. Yep. This is not pretty, but.
Bean, I think seems like you want to do.
Let's see if this. Okay, so we're getting the wing stuff. So these are all of the commands.
Yep.
Let's try compiling hello.w.
Okay.
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 And
kind of compiling without any targets from some reason compiled defaultly to the AWS.
Yeah. So we can also say. Let's say we want to compile to the simulator.
Okay. And it works.
We saw this WSIM file.
Yeah.
Now, it won't work out of the box with the console, unfortunately, because the console kind of has its own version of the SDK working under the hood.
Interesting.
So we have some ideas for how to switch this. So it'll be
because the console is also doing Wingit, which does wing compile. So it's kind of.
Yeah. So when you click invoke in the console, they are invoking their own version of the SDK. I think that we have some ideas for this.
Awesome.
But for now, you'll have to take it on my honor.
Yeah. Okay.
You can write a test.
Of course, yeah. We can also write a test.
Let's write a test.
Yeah. So okay. Let's see. In flight. To see if I remember all the wing syntax. Let objects equals bucket.list. Okay. And assert. Do we have length?
Yep. I think we have length on objects.
I don't know.
Not length.
I want to say
not
it's like,
length. I think we have. Let's see.
Let's try this.
Yeah, that's right. No, you need to do wing test. You missing. You need to have as test for the function here.
Good call. Okay. So this basically says file is added. We'll just document it.
Yeah.
Be a good Boy Scout. Okay. Entry point.
Yep.
Hello.double.
Just create a test resource.
Yep.
Okay.
So what did it fail?
So saying the length is not 1.
Yeah, I'm not sure that. I'm not sure that is. It's probably undefined. I'm not sure. Try length for a second.
Yeah, let's also try length. Let's see if that's.
Yeah, it's like.
Yep.
Oh,
Yep.
hey, it works.
Oh my God.
I didn't expect that.
So let's see. I mean, you want to see it? You want to see this? The index HTML? Let's do this.
Yeah. Okay, so let.
Content. Yeah. Content equal. Great.
And then
the print's not going to work well, so do assert with an empty string or something.
Yeah, sure. Let's assert
With something, with exactly.
And now we should get an error.
Oh, and we should see that. Oh, that didn't work. Index HTML.
I mean, we are getting an insertion failure, but it's just not showing the contents.
Okay,
right?
it did work. Okay, so it did work. Okay.
So let's try putting the string in
yeah,
and make
yeah.
sure that
You
it
can
passes.
just throw.
yeah,
Okay, we got another idea from the audience. We can try throwing.
yeah, that's nice.
Let's try throwing contents.
No, it's not gonna work. So.
Oh, hey, we got the error of
we have
the
throw,
contents.
right? Nice,
Very nice.
nice. So it worked.
Yep.
My God.
So what are the last things I would need as a contributor to get this feature?
Yep.
Well, we gotta add some unit tests. I don't know if we have time for it today.
Yeah.
But you can see, just to see an existing test, basically you create an app,
Yep.
you start the simulator,
Nice.
you obtain the client
Yeah.
based on the resource's name, you try calling stuff, and then we're just using just standard TypeScript library. So
Great.
if you're familiar with TypeScript, it'll be pretty natural to you.
So how would you write the test here? Would you just start simulator? We basically once the simulator
Yeah, so we
started,
call add
Yeah.
object before starting the
Yeah,
simulator.
Exactly.
And then assert that we already have one object.
Yep. Makes sense. Awesome. Thank you, Chris.
It's my pleasure.
So again, we don't have Mark the DJ here today. So it's we're gonna take a musical break without his voice and commentary. So let's take a musical break. Hey,
Hello.
how you doing, man?
Not nervous at all.
Not
Everything is
nervous at all.
working just fine. Didn't just make a pull request a few seconds ago.
Really? Wow. What's going on? Okay. First of all, thank you for coming.
Twitch-based development.
Yes, it's actually something that's really happening to us, right? I mean, we were talking about this before, kind of, how we're gonna, we all believe in deadlines.
Yeah.
Yeah. And it's very hard to create a strong deadline because we're all also engineers. We know how things fucked up. I mean, you try to write something, it takes 2 days more. It's very hard to have deadlines. And the show is it creates deadlines. We gotta
It's a
go over
forcing
the thing.
function.
It's a forcing function. It's pretty awesome. It's a
Yeah.
nice. It's a nice.
Twitch-driven development.
Yeah, Twitch
Yeah.
driven development.
When the going gets tough, the tough get going.
Yeah. So we have Shai here with us.
Hello.
Shai is the acting CEO, the people for the co-founder and a great guy.
That's debatable.
That's not debatable. If there's something that's not debatable, it's that. You're here to show us basically the contribution guy. So what are you here to show us? Actually?
Yeah. So we're gonna talk about contributing to Wing, basically. And first thing I'd like to thank, and I think all of us would like to thank everyone that has contributed to Wing and is contributing to Wing. And it's important to note that contribution is not just, GitHub counts people who contribute code. But there's so much more to contributing to a project, right? Like you can ask a question on Slack, that's contributing to the community. Someone sees it later, sees someone replying. You can reply on Slack. You can ask a question or reply on our discussion boards. You can open an issue. You can open an RFC. You can comment on an issue on an RFC. So there's lots of things that people can do to contribute, and each and every one of those contributions really helps. And we thank everyone, and I think that we were pleasantly surprised by the amount of contributors and contributions and the quality of contributions that we have at this stage of the project, when Wing is not really usable for building real-world applications. For me, it was surprising that people cannot really build anything with it, and still they feel like, I don't know, maybe they like they see the project and they think it's going to be a success, or that's going to be the future of writing code for the cloud. And
I totally agree. I have the same exact kind of feeling. I was surprised. I mean, people are kind of contributing. They like it. They like working with the community, and people are actually doing work, amazing work. And it's fun. I love this.
Yeah. So shout out to all all the contributors that are helping out, and to Revital, who's keeping everyone happy and functioning.
Yep.
So that out of the way, and also kind of buying some time for my PR to get published.
Oh, where was the PR exactly?
It's coming up.
Okay, it's coming. Okay.
Yeah.
Okay.
Yeah. If anything goes wrong, just cut for commercials, and I'll run away, and you'll be left here alone to.
No problem. No problem. We'll do that.
Okay. So basically, we have a contributors guide, and we can walk a bit through it. So I think we just discussed how everyone can help. Maybe there's a thing or two here that I didn't mention. And then we talk about how the repository is structured. So basically, very simple. We have an apps folder and a libs folder, where the apps is everything that users can run, and the libs is all the libraries. Don't think if I need to explain it further, probably you're not on the right place.
Yeah.
And then it goes on, but I think for brevity, we'll just skip ahead to the development workflows. That's the main entry point for anyone who wants to contribute to the project. So what we have here is basically an environment setup. So we have the different tools that anyone needs in order to contribute to Wing. Some of them are needed just for the compiler. Others might be needed for other parts. But basically, if you want to compile and run the project, you need all of those tools.
Yeah. So this page basically kind of takes me from someone who doesn't have even Node.js, Rust, IC, CLI. I mean, doesn't have them installed. I haven't cloned the Wing repo, to a point where I can compile Wing and run and basically compile it and use it to compile Wing software.
Exactly.
Okay.
And any contributors out there, so basically you see this list, I guess you have like in your head, you shout, why don't you have a Docker image that already contains all of these prerequisites plus our repo? So that's a good first issue. You discussed it before.
Right.
And that's a step before. Just if we have this, then it's a very short step to actually creating GitHub workspaces that someone can just contribute with the click of a button. So open for contributions.
Nice idea.
Yep.
So you're going to take us through this, basically?
Yeah, I'm going to take us through the beginning of that. It's basically once you have the beginning, you kind of have it all.
Okay.
And also, rumor has it that not everything here
works. Okay.
Yet.
Okay.
We're on it. So let's start. Let's clone the repo. So I'm gonna be working on Visual Studio Code. And
okay, so we're creating.
Yeah, so we're just
cloning
the repo, just then changing directory to the repo, and then doing npm install.
Yeah. You mind setting the font a little bit bigger?
You know how?
Yeah, I think I know how.
Great.
Maybe I don't know how.
It's a good thing I'm a CMO and not something technical. Otherwise, it would have been embarrassing not to know.
No, you have good. That means that you have good eyesight. That's what it means. I'm looking like this and say, "Do you mind getting?" I don't see anything anymore. I mean, okay.
Okay. So it seems to have worked, and we need to update our dependencies, but that's for another day.
Yeah.
And let's see. We need something else, another step here to add our WASI setup. So obviously I already have this on my machine, but just so you see it doesn't make your computer explode. So we'll just do it.
Maybe I switched to Hebrew at one point with my. I was pressing everything on your computer. I had to go to my computer. No, it's in Hebrew. I had to go to my computer to figure out what to press. I mean,
okay, let's see.
You're in Hebrew.
Yeah. Okay. No. Now.
Okay.
Now I'm good. Okay.
Yeah.
I guess this part we can cut out
Yeah,
later.
exactly.
And okay, so development iteration. Let's just see if my PR got published. Not yet. Never mind. Let's continue. So basically, as you can see here, we're using NX. I think that's a time to maybe discuss our mono repo. So basically, our as you can see here, the structure of our project. We discussed we have the apps here. We have the libs. Obviously, we have examples and docs and everything else. And everything is in one mono repo.
Yep.
So basically, now you're going to ask me, why do we have a mono repo?
So was it always that we had monorepo? We didn't start from a monorepo, but
Right.
we moved. Why did we move?
So we started with many, many, many different repos. Actually, we were, I think, 2 months in the project, maybe 10 people, and we had 30 repos. So
Okay.
it was kind of an insane situation.
Yes.
And we had many reasons to move to a mono repo. I think first one was to help contributors to get oriented and know where to go and what to change. And also to concentrate all our efforts on one place. So you have one place to document, you have one place when contributors go into your code, so they look at one thing, one entry point. Another reason was because some of these projects are dependent on each other. So what does it mean to have an SDK, like our standard library, without the compiler, or vice versa? Basically, when you update the version of one, you need to also update the version of the other. So it made sense for us to move to a mono repo, and we're using NX to manage everything, and we've been happy so far.
And we're optimizing the contributors. Yes, this is something. I mean, this is part of. I mean, this setup needs to be comfortable for people.
And contributors' experience, and also we're optimizing for our own experience, because we want one place. Like when we direct someone to our repo, we want to direct them to one place, and not to a place where for different repos for different needs.
Okay.
So we may have bought a few.
This is what you're trying to do. You're trying to buy time because to see something different here. Okay.
No, it's not buying time. It's like very important stuff that we need to to discuss. Never mind. So actually, we have our mono repo here, and basically NX, and we can do npx NX wing from the root to build and run everything.
Okay.
If you want to do it, we can do it. If not, we can. We
don't. We can skip this. I mean, just to see this.
Didn't I you need to
I'm
buy time? No. Okay. So let's skip. And basically, the last part is just to run wing, but not through the binary that was pre-compiled that we use in npm. That we use npm to call. So we have this part. That's like. We're not going to use it now. It's just for debugging. And then we have this command, basically npx NX wing, and then we give the CLI arguments for wing. So we're not using npm here to get the wing compiler. We're building the wing compiler, compiling it, and then using it. And all of the compiler dependencies will get compiled. Those that have changed before. So let's. Have some example here. So we have npx NX wing compile. So you can see that I played with it before.
Yep. Of course.
But
So this is going to run the wing command that you.
Yeah. So it's going to run the wing compiler with the compile command on this file. If I remember correctly, we need this this fix for the relative path. And let's see what happens. So it sees that there are 4 dependent projects.
Oh, interesting.
Yeah, and it's going to compile all of them, and then compile wing and compile this file.
Wow. So that's really awesome. So it does all of this. So it compiles it and then it runs it. That's nice.
And then we'll be able to see here. This is the apps, and we have the wing, and we have BNSRC, and now if everything works, it should create a target
directory.
Yeah.
For the output of the compilation.
Yeah. Exactly.
Makes sense.
So let's see what happens here. Drum roll, please.
Should have done longer.
Yeah, but you can see here we have the target.
Okay, nice.
And in the target we have CDK Terraform
Yeah.
out. For anyone who's already played with Wing or have seen our previous shows, this should be familiar to them. And then we have the CDK Terraform with everything in the example. We'll show the example. Probably we should have shown the example before. And then here we have the different Lambda functions that were compiled.
You want to show the example for a second, just for me to figure
Yeah.
out? I mean, the
So we have the example.
we're using the capture, right?
Yeah,
Yeah. Okay.
the tests,
The test, right?
valid, and
Captures. That's
Yeah.
exactly.
So
So we have we have two buckets
we have
here,
two.
3 buckets here. We got a queue, we got a Lambda function, another cloud function, another cloud function,
and
another function. Yeah, I see.
So 3 functions,
Yeah.
which we've guessed from the compilation target, and then sorry,
I don't think it's here. I think
it's in the apps, and then we have the different functions.
Yeah.
I can
Another function,
make
exactly what we
this-
saw.
Yeah. Oh, sorry.
Yeah, and this is the zip file.
now it's small. Where is it?
Do you want to unzip it?
Yeah.
Yeah. Open with maybe revealing Finder. Maybe
Yeah.
revealing
Let's
Finder.
reveal
Yeah.
Finder. Do it.
Yeah. And now you have the index file.
Yeah.
Yeah.
So that's the compilation
The
result.
actual compilation result.
Yeah. Another command we can try.
Okay.
Don't try this at home, kids.
Okay.
We can try to do the test.
Oh, nice.
Right, Elad?
Right.
Theme
Interesting.
of the show.
Yeah.
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 The test or right, Elad?
The test.
No, it's a nice
right.
theme for the show. It's a
Yeah.
very strong capability.
Okay.
Okay.
So you can see it
Nice.
compiled the file.
So
and
it doesn't have any in-flight test. So we saw this before
Yeah.
because it doesn't have any in-flight test. It's basically it passes.
Yeah.
So, yeah.
Exactly. So
It's
so it works. Let's see. Maybe now, not that we need it anymore, but no, still is not published.
Okay.
But the instructions go on, and you can compile other parts. Basically, we have many different parts. We have the VS Code extension, and we have our playground, and we have our SDK, as you've seen before,
Yeah,
and we
right.
have many different parts of our ecosystem. And for each and every one, there are instructions how to compile, how to build, and how to contribute to them, and contribute code. There are other types of
Right.
contribution.
Nice.
And anything else you'd like to know?
No, I think this is going to go through the entire process. It worked.
Yeah.
You had to work really hard to make it work, I know.
No, not.
Not really
really.
hard? Not that hard? Okay. And I think that's good. I think that's something that hopefully we can package and put this somewhere in our docs so people can just go through. I mean, if you're going to
Yeah,
edit this thing.
it's already packaged. We just need to tweak the.
No, but even this video, we can actually kind of post
Yeah.
a video of this, kind of cut and paste this nice stuff.
Cut.
Yep. Yep. And I think it would be a nice addition because I haven't contributed yet, and it looks pretty simple, to be honest. I mean, this point
Yeah.
to compile and run it. It
And
looks
think
pretty
how simple it will be once we have the Docker image or the
Yeah.
GitHub code spaces.
Yep.
That would be
Yeah. So
Awesome.
good first issues.
yeah.
Awesome.
Take it.
Great. So thank you very much. Well, the
Thank you.
applause, guys. Thank you very much. It was fun talking to you and interesting. And thank you for everybody here, part of this crazy production and supporting us. What we ask for you, basically, I mean, someone told me, I think it was you even, Chris, someone told me, you shouldn't say bye at the end of the show. You need to ask for something or kind of something that makes more sense. So go through our contribution docs, try it. I'm going to give you a second. Try the contribution docs, go through the docs, make sure that everything works. Let us know if it doesn't so we can improve. What did you?
Hassan Zarfsi.
Hassan Zarfsi? What about it?
he published an RFC about infrastructure policies.
Oh, really? Interesting. I haven't seen it yet.
The Wing plugin system, it's called.
Really? Okay, so we have an RFC. Basically, is it a pull request? Great. So we have a pull request right now. It's called the Wing plugin system, which basically talks about our infrastructure as policy. So we mentioned before in this show when we talked to Chris about that Lambda function, whether this is a Lambda function or what can I make of it. So
this
RFC,
so we have an RFC by
Yeah.
Hassan, Wing plugin system, and it's a very nice read, not too long, so everyone is welcome to take a look and comment.
Yep. Awesome. Great. Haven't seen it yet. When was it added?
Just now.
Oh, nice. Okay.
Yeah. Thank you,
Great.
Hassan.
Thanks, Hassan. Yep. So goodbye. And,
Now you need to ask another thing.
what should I ask?
I don't know, you said goodbye, now you need...
Yeah.
Okay, so another ask.
Another ask.
And
okay.
no goodbye after that.
Okay.
So, like we said before, the Docker image for the
Oh,
contribution, or for actually working with Wing, that's another Docker image that we need.
And now we need to fade.
Yeah, so long.